Okay, so when we're looking at algebraic models and different things like that, different formulas, what we're actually talking about is a relationship between two or more variables. So a formula is something that we can tell different things about. So like distance, time, and speed, well, that gives us kilometers per hour, but we can also find out how far we've gone or how long it's taken us to get somewhere. Now, when we're looking at questions like this, for example, the area of a triangle can be determined using area. Sorry, I'm going to make that a little smaller. So area equals 1/2 base times height. So if we're working on that, so 1/2 base times height, well, that's going to help us out, but what do we really know here? Well, first, if we're trying to find the base, so if we have an area of 6 meters and the height is 3 meters, we're trying to find the base. There's really two ways you can do it. You can substitute and then solve, or you can rearrange and then substitute. Now, sometimes, so if we were to do one, so we'll substitute in first, so in method 1 here, times the base times the height. Well, we know we can multiply all the things on the top here, but to get rid of this fraction, I could multiply both sides by 2, or I could actually just multiply this 2 up to the other side because I just have one term. So if I multiply both sides by 2, I'm going to get 12 here. 6 times 2 is 12. And then I'm going to get b times 3 on the other side. Well, now I have to divide that 3 over, so I'm going to get 4 equals b. So b is 4 meters. The other way I could do it is rearranging first. Now, sometimes rearranging first is actually easier. In this case, I don't think it really matters, but if we were to rearrange first, now I'm going to write the whole formula out. I realize it's right above, but we have b times h over 2. All I've done is multiplied the b and h into that 1, and it just looks a little cleaner. So then we get 2a, because I'm going to multiply the 2 over, equals bh, and then 2a over h equals b, and now I can substitute in. 2 times 6 over 3 equals b, 4 equals b. 2 times 6 is 12, divided by 3 is 4. Okay, and again, it's 4 meters. We can use formulas to rearrange for different variables depending on the formula. So formulas can be rearranged to isolate a certain variable. One of the most famous chemistry formulas is PV equals nRT. Now, R in this case is a constant actually, so we would never solve for it. It would be depending on what we're using or what we're finding is what the constant would be. But P, V, N, and T are all different variables we could solve for here. For instance, P equals nRT over V, but N equals PV over RT. Okay, and we could actually go through and solve for each of those variables and use the different substitutions to find out the other ones. Let's look at some more examples here. So rearranging the formula to solve for the indicated variable. So we actually don't know what any of these are equal to, but we know we can rearrange these formulas. So D equals A plus B. We're talking about triangles here. We want to solve for A. So in this, what I have to do is I have to look at this. How can I get that B to the other side? Well, what I need to do is subtract it. So we're going to have A equals D minus B. Now, I know I flipped the side of the equal sign, but saying 2 equals 1 times 2 or 1 times 2 equals 2 is the exact same thing. So I'm just writing it a little more clean. Now in this question, the next one, the velocity, this is the speed question we were just talking about. So speed equals distance over time. Well, to get that t to the other side, we have to multiply it up. So distance equals speed times time, or VT. Moving on to the next one. We're solving for R here. This one's a little bit harder. What we have to look at is we've got area equals pi r squared. Well, we know that that's pi times r squared. So the first step would be area over pi equals r squared. Now, how I get rid of a square is square rooting. We talked about this a couple notes ago. So what we would have is the square root of a over pi, and I'm square rooting the whole thing equals r. And that's a little bit tougher, but that one's, it's not too bad. The last one, y equals mx plus b, you're going to have to get very comfortable with this formula because it's one of the most common formulas in grade 9, if not the most used. We're solving for m, and m in this case is called slope. So we have to do reverse BEDMAS. So we have to do adding and subtracting first. So adding and subtracting, I need to get rid of that b value first. So I'm going to subtract it over to the other side. Y minus b equals mx. Then I've got m times x, so I've got to divide by x. So I actually have to divide the whole other side by x. I can't just divide one or the other. So we're dividing the whole other side by x equals m. And we're all done. A couple other things here. If you look at those two questions, when I took the square root, I took the square root of the entire side, a divided by pi. When I divided by x in question 4, I divided by the whole thing. So I did y minus b over x. I didn't just use the y, I didn't just use the b. I did the whole thing. And in each case, we're actually doing reverse BEDMAS. Okay, we're doing the opposite order of operations here. Here's some questions associated with this.